Hello everyone, I'm George. Welcome to my channel. Today we're repairing a 6 kilowatt inverter, 48 volts. So let's disassemble it, see what's inside. Okay. Try to rotate it a bit. It's really heavy. It's like 40 kilograms because of the transformer. It's a toroid transformer. Screws coming off. The board taking. You can see the transformer over there. Let's see the fuse first. Fuse is good. So this has a problem with the logic board or something. Let's see some transistors. This one's okay. This one's okay as well. I think this is the power supply for it. It has a burnt resistor. This one here. Maybe it's just the power supply, but it can be tricky to repair because the integrated circuits are all sanded, unfortunately. As well, we have a melted capacitor over here. This one. I'll disassemble that and let's see if we can repair it. Does it click? The clicky one. Okay. This is the out live. This is the plug in front, the wall plug in front. This is the cable with the screws at the back. That was live. This is neutral. This is inverter out, transformer out, live. And neutral. This is the power supply for, this is 48 volt for the power supply, just plus and minus, and this is probably the fan. Yes, this is the fan with a click. Okay. This is the power supply. It's not that complicated. It's an old style. This is probably 3844 or 3843. I don't have the value for this resistor, but I will ask for pictures from a working inverter. I'll clean it up and we're coming back to it. Coming back to fix this board. I changed these parts. This was swollen. It's on the AC part, this one over here. This part is completely separated from this part, which is the power supply. And then I found the burned MOSFET and the 200 ohm resistor, which is I don't know if you can see it. It's this one here. If I'm not making sense today, you should know it's because of this. Not even the camera is focusing today. Just had the COVID. It's the 4th day. Now I'm okay. To test the power supply, I assembled a step-up converter, and I put the power button as well from the inverter. Shorted these 2 pins on this jumper over here. Now we'll check some voltages. Let's see. We put these. No. Like this. Okay. There are more voltages on this board, so I can see a ground here and the 5 volt here. 5 volt, and then a 12 volt here, more or less, and then a 20 volt, 24 volt on this capacitor here, more or less, and then 10 volt on this one, and then I can see here 5 volt on this capacitor, 15 volt, 15.4. So this came out okay. I have more boards here. I have 2 brand new and two that were used as donor for parts, which I will repair as well. So I thought, why not try to repair this board. It was quite easy instead of using a new one. Now I'll put the logic board as well. On all these boards that you see here as well, all the components are sanded, so it would be quite tricky to repair them. But I'll try sending an email to the producer as well. Maybe he will tell us what chips he used. This one especially, I think it's a classic PVM chip. Put the logic board, power on. That's probably an alarm, but it works. I'll put it back in the inverter and let's see what happens. We're going to try to power this up again with batteries. First I will slowly charge the capacitors because it has so many capacitors in it. Now it's in standby. So if I'll go clockwise, it's running. I can hear it buzzing. Now if I go counterclockwise, it's in standby. No, yes, it's stopped now. So it will start only when I have some kind of power drawing out of it. Now it's in standby. So this is running with power supply that we repaired. Should be okay. It's purring so nicely. It's a very solid inverter. Take the power out. Let the capacitors discharge. Okay. I'll just take the dust out of it. We'll try to repair next the power board that it's pretty burnt.